started as a middle school science fair project, but now one Pennsylvania 14-year-old says he knows how to save the government $370 million. All it has to do is make one simple change.
So what I propose is that the government switch the font that they're using for all their documents to a particular font called Garamond.
Isn't this genius? Look at that. I mean, it's not that much of a difference either.
Last year, Suvir Mirchandani set out to discover how his school district could save money and conserve resources through experimenting with different typefaces. International Business Times says Suvir looked at 4 different fonts: Garamond, Comic Sans, Century Gothic, and Times New Roman. After weighing letters printed in those fonts, he discovered Garamond used 24% less ink and would save his school district $21,000 annually. Suvir was later encouraged by his teacher to work with the Journal of Emerging Investigators, or JEI, which is a publication for the work of middle school and high school students. JEI urged Suvir to look at his project more broadly, specifically how he could save money for the federal government, which spends $1.8 billion on printing each year. Using the same methods he employed for his science fair project, the Consumerist report, Suvir found the federal government would save $136 million a year on government documents, as well as another $234 million if the state government started using the lighter and thinner typeface as well. While the government print office says Suvir's results are remarkable, its public relations manager told CNN the office is currently working on shifting government content to the web to be more environmentally sustainable. But Suvir, who sat down with a news outlet, says he's okay with the government going another route.
My goal is just to get a few individuals to change, which would personally save their costs. Right now, I'm simply working to spread the word.
Suvir's findings were published in JEI's March 2014 issue. For News EMSAC Tunes.
All right, guys, welcome back. With that video, I just thought it was kind of neat because here is a teenager who took a simple idea, applied it, and I mean, look at the findings he had. He could save the government millions of dollars just with the thought of, switching a font size, which is a simple idea, but sometimes the simplest ideas are the best ones. So I thought that was fairly interesting, and I just wanted to share that with you. All right, now part C. We are in the back of our Solving Right Triangles notes. Okay, what we're going to take a look at here. Now, these are the ones that are a little bit more involved, strictly because notice they didn't give us an angle. Okay, so what we have to do is we have to find this angle. So I'm going to go ahead and call this angle A down here. So I'm going to use this as my reference angle. This is angle A. A is opposite, 4 is adjacent. Here's your hypotenuse. Now this is something new, but what we do is we say sine of A equals opposite over adjacent. Oops, sorry. I want to use O and A because I have 8 and 4. We all make mistakes, even me. Okay, so I want opposite and adjacent because that's the two that has numbers there. So 8 over 4. So if you'll notice, I have tangent of A equals 8 over 4. Now, here's our new thing. What we were doing for a while was we were doing tangent of blah, blah, blah. Okay? But when you want to find an angle, we have to do tangent inverse. Now, I know it's hard to see with the glare here, but you see how it's blue behind the tangent button? My little finger down here. In order to get that, we have to hit second, tangent, then you type in 8 over 4. And as long as you are in degree mode, it'll give you your angle, 63.4. Okay, so angle A equals 63.4 degrees. All right, we only do that for when we're finding angles. We do second of sine, second of cosine, second of tangent. And it does look like this on the calculator, so you see it. Tangent inverse, -1, 8 over 4 equals A. All right, so in order to find angle B, well, let's make our lives easier. 90 minus 63.4, 26.6. Okay, so angle B is 26.6 degrees. Angle A is 63.4 degrees. All right, we got all of our angles. Now to find C, we can use a trig ratio, or we could always go back to a squared plus b squared equals c squared, just to give you guys some options. 4 squared plus 8 squared equals c squared. 16 plus 64 equals c squared. 16 and 64 adds up to 80. The opposite of this would be square root both sides. And since we're doing everything in decimals, I can just type in square root of 80 gives me 8.9. Okay, 8.9. So again, the difficulty here is just with the new angle idea with the inverse, trig inverse. Okay. All in all, though, finding your missing sides is a little bit easier because we're just using Pythagorean theorem. Okay, down to part D. Same idea. I'm going to call this x because it's my side, or actually I can call it little e, lowercase e, since it's across from capital E. I don't know an angle, so let's start with u. Across from u is your opposite. Here's my hypotenuse. Here's my adjacent. Now, since I'm trying to find the angle, we need to use the trig ratio that uses O and H, which is sine. So sine of u equals 19 over 28, just your ratio, opposite over hypotenuse. To get u, I got to do sine inverse of 19 divided by 28. Okay, so I'm back to my calculator. How do I get sine inverse? Second sine 19 over 28. I know it's hard to see right now. I don't know why it's doing that. So we get 42.7 degrees. Okay, so there's my angle U. To find angle E, I'm just going to do 90 minus that. And we get 47.3. So angle E is 47.3 degrees. Okay. All right, now, lastly, to find lowercase e, Pythagorean theorem, e squared plus 19 squared equals 28 squared. Okay, e squared plus, my 19 squared is 361. My 28 squared is 784. Okay, subtract that over. 423, so e squared equals 423. Square root both sides, 20.56 or 20.6. Okay, all's well. So again, we've completely solved the right triangle. We have all the missing sides found. We're in good shape. All right, very last one then, use the diagram below to find the distance across the suspension ridge. So if we take a look here, number 2, we've got right angle, okay? I'm trying to find this entire distance. Well, I need to find just what's one little piece right now. Here's your reference angle, here's opposite, here's adjacent. So opposite and adjacent is tangent, so I can do tangent 32 degrees equals 52 over x. Okay, well, I'm going to go ahead and replace the x in tangent 32, so x equals 52 divided by tangent 32 degrees. And then if I go ahead and set this up, or I solve for it, 52 divided by tan 32, I get 82.2. Okay, we're talking about feet here. So what you've just solved for is this one little piece, but how many of those little pieces do we have? 1, 2, 3, 4, 5, 6. So I'm going to take 82.2 feet, or 83.2, is that what it said on here? My apologies, caught myself. 83.2 times 6. Okay, so 83.2 times 6, 499.2. And that gives us our total distance across the bridge. Alright guys, I hope this video helped. Again, that wraps up Chapter 9. Okay, so the most important chapter of the year is already finished up. I hope these videos have been helping. Please feel free to add questions or ask questions in class if you ever need help. And as always, good luck. Keep up the good work. And we're all counting on you.